Okay, here we go. We're in chapter 1.5. We want to be solving inequalities. So you know those things with less thans, greater thans, and all those great words. We're not using equal signs, we're using inequalities today. So we want to talk about the very different ways we have to represent inequalities. So we have these multiple representations. So we'll start with the inequality notation. Okay, so the inequality notation is what you're familiar with. X is greater than 4. Okay, so that's easy, and we should have down pat which way is which. The bigger opening opens to the larger value. Okay, but then there's a second representation we're going to use. And this one is called interval notation. So this is an interval. Let me get back to my pencil. No, pencil, interval. There we go. Interval notation, it's going to look like an ordered pair, but it's not, okay? So you have to use your context. I'm talking about inequalities, and this is the interval. So the x is implied, so it's going to be any variable is implied. This side here refers to the leftmost or the lowest or the least, okay, possible value, and the one on the right stands for the greatest value possible. Okay, so you're going from the left to the right. How far would you be going? You'd be starting at 4, and you'd go on and on forever and ever, so there's really no end, and we write infinity. The other thing to note about this is that I'm using round parentheses. Okay, and that's because you use the round parentheses when you do not include the value of 4. Remember, I have to be greater than 4. I cannot be equal to 4. So it's round. It's just sort of getting around the 4 without being on the 4. Okay, then we have a different notation, graphical. Okay, so you can graph these things. And of course, you're familiar with the number line. Remember, you have to have the two different 0 and 1 is a good place to have on there. I'll do 2, 3, and 4. I want to be greater than 4, so above my number line, in this space above there, I'm going to put a circle at the 4, and then I'm going to do the arrow that points to the right because I want to go greater than 4. Okay, and what's interesting to note here is this has to be an open circle to not include the 4. So again, you're going all around the 4 without being on the 4. You're not going less, so maybe all around in this case isn't such a great way to say it, but you're not on the 4. There's a hole at the 4. And finally, we should be able to translate into English words to describe that x is greater than the 4. Okay, so those are the 4 different representations of this inequality. So let's see what changes though when we change the inequality. So this time we're going to say x is greater than or equal to 4. Okay, so right away you heard me say x is greater than or equal to, but there's another way to say that too. Okay, another way to say that is x is at least. See, I had to stop and think about that. So let me back up. It's not going to let me do it. Let me cross it out. Is at least 4. You start the leftmost value, the least value is 4, and then you go on and on forever to the right, to the greater than. So how would we write this in interval notation? I'm going to start at 4 again. But this time I want to include 4, so I'm going to use square bracket. I'm going on and on into infinity again, but infinity cannot be included because it's not a number, so you just keep that as a round parentheses. And then the graph has to look a little bit different. Okay, I still have my 0, 1, 2, 3, and 4. At the 4, though, I'm going to do a closed-in circle as best I can, and then the arrow to the right. So here it's important that I have a closed circle to include the 4, and here it's important that I had a square bracket to include the 4. So all of these include 4. So you could say x is greater than 4 including 4 would be another way to write it in words. And of course I could go through these multiple representations with less than as well as less than or equal to. Everything is the same except my arrows would be pointing to the left. Okay? So maybe I'll let you try some of those on the next page. Okay, here's a couple for you to try. I want you to do all 4 representations of x is less than 5, and then go ahead and do the same thing giving all 4 representations, and I've already given you the first one. This is the inequality notation, right? So give me the other 3 for both of these questions, x less than 5, and then again for x less than or equal to -3. Pause it, and then we'll check our answers. Alright, so you can see my answers. I said if x is less than 5, then it can be as small as -infinity, so all the way out to the left of that number line, heading back to the right on the number line all the way up to 5. Okay, but do not include the 5, so it's around parentheses. And the same reason you do not include the 5 makes it an open circle here for the graph, and then I go to the left, and x is less than 5. And then when I go to the x is less than or equal to -3, all I'm going to do is make sure this is a nice square bracket, and this is a closed-in circle. I do like to write the words x is at most -3. It's almost easier to write those words looking at the graph, right? Doesn't that seem to help you a little bit? Or even the interval notation seems to be helpful. Alright, let's try something else. Okay, I want to talk about some of the properties of inequalities. There's a whole list of them in your book, but the ones I want to talk about, make sure we're very clear on. If you start with a is less than b, then it's perfectly okay to reverse the order, b, then a, as long as you reverse the order, the direction of the sign. Okay? And what you notice is when you do reverse both of those, the b still has the wider side in both cases, and that makes it okay. So a lot of times you'll get down and you'll solve an inequality, and you'll get it down to, maybe you'll get 3 is less than x, and you're not happy with that because usually we like to write x is greater than 3. I will accept either answer because I have no problem whichever side you want to put your x's on. Okay, so either one of those is fine. I'll remind you of this sort of a transitive property. I think we covered it in geometry last year. And if a is less than b, and it's also true that b is less than c, then it has to be true that a has to be less than c. And that's real nice and easy to see if you put it on the number line. Say here's b, a is less than b somewhere. I have no scale on this number line. And you also know b is greater than c, then it's pretty obvious to see that a has to be less than c as well. Okay, so that's just a nice property. But here's the one that you're really going to need to remember, and it's just something you always just have to be watching out for. If you start with an inequality and you want to multiply both sides by a negative number, so let's say c is negative, okay, and the way we write that is c is less than 0, then it has to be true that CA is greater than CB. And what I did was I reversed the direction of the sign. In this special case, when I've multiplied both sides of the inequality by a negative number, I have to reverse the sign. So let's just take an example. It also is true for division. Okay, so maybe you already know this trick. If I ask -3a is less than 18, if you want to pause it and get your answer first, that's great. But in my case, I'm looking at this and saying I want to solve for a. All the other rules apply about adding things to both sides, subtracting to both sides, multiplying and dividing both sides. The same as equations, as long as I remember this trick. When you divide, in this case, by a negative number, like this, I'm dividing both sides by -3, the direction of the sign has to change. So I have a is greater than -6. Okay, so we are already starting to solve these inequalities like this last example, and in the future whenever you're solving an inequality, I will always be asking you to graph the solution as well. Okay, so I'll need the two representations, the inequality notation like this one, and I want to graph as well. So try another one. I'll give you one. And pause it, come back, and let's check our answers. Okay, I got x greater than 2. I graphed it, making sure I use that open circle. Okay, just like with equalities or equations that we were solving, we can do the sometimes, always, never game with inequalities as well. So try it with this one, see what you get. Alright, when I try to solve this inequality, my x's cancel and I'm left with 4 is less than 4. That is never true. Okay, so the answer to this inequality would be no solution. It's as easy as that, because that was a false statement. Remember, if it was a true statement, if you had come down to something that said 3 is less than 4, then that's always true. And what you would have said is x can be any value whatsoever. So maybe we'll say x is all real numbers, and the original statement had been an identity. Okay. It is true for all values of x, so therefore it was an identity. Alright, so that's quick and easy. Let's do one last thing. We want to talk about compound inequalities. Okay, here's a problem for you to try. 7 less than 2x plus 1 and 3x less than or equal to 18. So a compound inequality for you to try. Give it a pause. Alright, there's my solution. X was greater than 3, while at the same time x has to be less than or equal to 6. So in between these two values are the only ones that will work. And I was careful to close the circle, fill it in on the 6, but not fill it in on the 3. I will point out one other thing. There is a nice thing you can do when you have a compound inequality using AND. It can be condensed or collapsed into a single statement using, still have the two symbols, but in one statement only one x. So x lies in the middle, okay? And then you knew x was greater than 3, so put that on the one side of x, and you know x is less than or equal to 6. Put that on the other side of the same x. And that way you've kind of condensed it into one. It is nice when actually you start like this and you can actually solve the whole thing in this condensed version. So what you do is you pretend there are 3 sides to your equation, and same idea, but if you do something to one side, you do something to all 3 sides. So in this case, I want to solve for x, so I need to subtract 2 at first. Subtracting 2 from the left, minus 3, still have 3x. Subtracting 2 from the very right gives me 6. Now I'm going to divide every side by 3, minus 1 less than or equal to x, less than 2. And I've solved it in this condensed way. I'll graph it, because that's what we do with inequalities. I'm going to run from minus 1 to 2. And I know x has to lie between negative 1 and 2. So another way to represent using words a compound inequality that's an AND is the value x lies between. So I'm going to go from minus 1 with a closed circle to a 2 with an open circle. And I'm done. Okay, so the other kind of compound inequality was when you're using an or between the two statements. And here you have to make at least one of the statements true, but you don't need to make both true. So it's okay to have only one be true. So what happens, it gets interesting at the graph. So let's quickly run through how to solve this. I'm going to have minus 2m greater than or equal to, subtracting 5, I get 16. So m less than or equal to negative 8. Or, and in this case, 4m greater than or equal to minus 20 divided by 4. It's not negative, don't switch the direction. Negative 5. Okay, so I divided by a positive 4, right? So I did not switch the sign. Alright, so here's my two statements. Graph it on the number line. Let's see, I need a number line that has negative 8, 7, 6, and 5. Alright, I want to be less than a negative 8 would be good with a closed circle. So I've just made one of them true. Okay? Or, so now I have to make the other one true is also a possibility. Closed circle again, greater than. And that's my solution. There's no overlap. That's okay. It's not an intersection. It's a union. Okay, so this is a union of the two solutions. And it's all good. Everything almost except what's between those two numbers. So there's your solution. You want one to try? You can have this one. Go ahead and pause it, and we'll check our answers. Alright, and you can see my solution. I'll just point out it is important that you still write the or for your final solution when you're writing the inequality notation part of the solution. Okay, so that's it. See you in class.